Good morning, folks. Good afternoon. Here. Today we're going to talk about 2.8, graphing linear and absolute value inequalities. The objectives here, we need to be able to graph a boundary and identify the solutions to inequalities. So a linear inequality resembles a linear equation, but with an inequality symbol instead of an equal symbol. So again, just quick review, we have inequality symbols. We have greater than, we've got greater than or equal to, less than or equal to. And those are four inequality signs that we've got. Okay. For example, y is greater than negative 3x minus 2 is a linear inequality, and y equals negative 3x minus 2 is the related linear equation. Okay. The graph of the inequality y is greater than negative 3x minus 2 is shown at the right as a shaded region. Okay, so that shaded region here I'm going to highlight with my blue. I'm going to go red because the boundary is blue here. Okay. This shaded region is the solution to that linear inequality. Okay. Every point in the shaded region satisfies the inequality. What that means, okay, you can pick a point in the shaded region. I see a good point to pick, 0, 0. Okay, if we substitute 0, 0 into the inequality, 0, 0, that's 0 for y, and we're substituting in 0 for x as well. I have to stop here. Apologize. Okay. We're also subbing in 0 for x. Okay. We've got 0 is greater than negative 2. You see that is true. That satisfies the inequality. Okay. So that's part of the solution. That's why we shade that region. If you picked any point, if you picked this point, what? 3, 1. Okay, that satisfies the inequality. If you plugged in 3 for x and 1 for y. Okay, the graph of y equals negative 3x minus 2 is the boundary of the region. Okay, so that's just, you graph the line here. That's our blue. It's a dashed line. We'll talk about why it's dashed a little later on. This blue is just y equals negative 3x minus 2. It's a dashed line for a reason. Okay, it is drawn as a dashed line. We'll get to it right now, to show the points on the line do not satisfy the inequality. So points on the line do not satisfy the inequality. Okay. If the symbol was less than or equal to or greater than or equal to, then the points in the boundary would satisfy the inequality. So it would be drawn as a solid line. So for our less than and our greater than inequalities here, these will be dashed boundary lines. Dashed boundary lines. And for our greater than or equal to or less than or equal to, these will be solid boundary lines. Okay, and that's because the points on the line actually satisfy the inequality. Okay, so we'll look at example 1 here. Okay, we'll take a peek here at example 1 with this one's going to have a dashed boundary line. We're graphing the inequality x plus 4y is greater than 2. Okay, couple of different ways to approach this. This is in standard form, so I'm going to use the x-intercept and the y-intercept if you remember using that. Okay. So to find the x-intercept of this boundary line, okay, this is bounded by, again, I'm going to put the boundary line here is x plus 4y equals 2. That's what it's bounded by. So we're using that to find the x-intercept and the y-intercept. So x-intercept is when y equals 0, so we go x plus 4, so x plus 4, substitute 0 for y, 2, so then we've got x equals 2. So we've got the point 2, 0. So let's get our equivalent point over here. Okay, we've got 2, 0 is a point on this line. So now let's find the y-intercept, just because it's in the standard form. It's a little easier to do that than the do other things. So we've got, this is when x equals 0, so substitute 0 for x, plus 4 times 1, 2. And this gives us the point y equals 1/2. So it gives us the point 0 and 1/2. Right about there. Okay. We connect the 2 points to make our boundary line. Try to get this as straight as possible. Okay, hopefully you guys are using a straight edge. Oh, what did I do wrong? I already made my mistake here. Okay. Hopefully you guys recognize this should be a dashed boundary line. Okay, dashed because we have a strictly greater than sign. Okay. So back to square one. I don't want to have this incorrect on here, so let's go ahead. We've got our coordinate line here. Make it a little bigger anyway, easier to graph as well. So now I put my intercepts on there. And now I'm using a dashed boundary line. Okay, so now we want to see where the shaded region should be, where the solutions are. So you pick a point. Okay, pick a point that's not on the boundary line. So a point I see, easiest point to pick unless it runs through the boundary line, pick 0, 0. Okay? Substitute those values in. So 0 plus 4 times 0, we're substituting those in to the inequality. Okay? 0 plus 4 times 0, so 0 plus 0, is that greater than 2? No, that's not greater than 2. Not true. Okay, so that is not part of the solution. So that means we need to shade in the other direction, okay, above the boundary line. Okay, that's how we're going to graph these linear inequalities. I'll do 1A and I'll leave 1B to you guys. So let's take a look then at 1A. We're graphing 3x plus 1/2 y is less than 2. So similarly, we're going to use the boundary line. 3x plus 1/2 y equals 2. We'll find the x-intercept. That's where y equals 0. So we're finding the x-intercept. Substitute 0 for y. 2x plus 1 times 0 equals 2. So this gives us 3x equals 2, or x equals 3/2. Okay, so that's our x-intercept, so we can graph that on a coordinate plane. Okay. That's going to be right between 2, that's 1.5, 3/2. Okay. Now we need to find the y-intercept. Okay, let me extend this page here. Got a little more room. Okay, and find the y-intercept. That is when x equals 0. So 3 times 0 plus 1/2 y equals 2. So this gives us 1/2 y equals 2. Multiply both sides by 2. That gives us y equals 4. So the point 0, 4 is on the graph. Okay. This one will be, again, a dashed boundary line. Okay, it's a strictly less than inequality, so this should be a dashed boundary line going through those 2 points. Again, we want to check which direction we should shade. Again, 0, 0 is not on this boundary line, so I picked 0, 0. That's an easy point to plug in. We're plugging that into the inequality 3x plus 1/2 y less than 2 is less than 2. Okay. We're substituting in that point 0, 0. So 3 times 0 plus 1 half times 0. Is that less than 2? Is 0 less than 2? Yes, check. That is a solution. So we need to shade in the direction of the point 0, 0. So we are shading in the direction of the point 0, 0. Shading below the boundary line. All right. Easy enough. You guys go ahead and try 1B. After you're done with that, we're going to go ahead and look at absolute value inequalities. Okay. Oh, actually, we've got a solid boundary line. We'll come back to the word problem. Okay, I think we have time. All right, so graph the absolute value inequalities. Graphing absolute value inequalities is similar to graphing linear inequalities. First, you graph the absolute value equation. So in this example 3, first we're going to graph y equals the equation, absolute value of x minus 4. That's our boundary. It's not a boundary line necessarily because we know these kind of look like these, but that's our boundary. Okay, and it follows the same lines along solid or dashed versus greater than or equal to or greater than or less than or equal to or less than. Okay, so it looks like this example is going to have a solid boundary line. Okay, because it's a greater than or equal to inequality. So let's graph our solid boundary using our translations that we found yesterday. We know the bottom of this V. Okay, just going to be down here. It's going to move from 0, 0 down 4. And we should have our solid boundary here. Okay, and we got to do the same check. Okay, we're doing the same check here. Pick a point somewhere on the graph, see if it satisfies the inequality. Again, 0, 0 is now on the boundary, so I'm picking it. Okay, 0, 0 is a very good point to pick. We're plugging 0, 0 into our inequality to see if it satisfies the inequality. So 0, that's greater than or equal to the absolute value of 0, which is 0 minus 4. So is 0 greater than or equal to negative 4? Check. Yes, that's true. That is a true inequality. So we're shading in the direction, okay, of 0, 0. And we have graphed the inequality. All right. So that's going to do it for today. Absolute value, we just graph the boundary, the absolute value equation, determine whether it's a solid or dashed boundary. And we're just picking points to see if it satisfies it. Okay. If it does, okay, then we shade in that direction. If it doesn't satisfy it, we shade in the opposite direction. Okay. That's with linear equations and absolute value, or linear inequalities and absolute value inequalities. So thanks for watching. Hopefully you found this helpful. Okay. Have a good afternoon.